Sailors and surfers can attest to the power of the sea. Tides rise and fall from the interplay between Earth's rotation and the gravitational forces of the sun and moon. Waves develop from the pressure and friction of winds blowing over the open seas. Humans have a long history of harnessing tidal and wave power. The ruins of a tide mill used for grinding grain on Stratford Lough in Northern Ireland date to 619 AD. On a larger scale, a tidal power plant on the Rance River in northwest France has generated 600 gigawatts per hour annually since 1967.
In terms of the tidal energy is the marine equivalent of wind energy. And you know that if you run your hand through the wind, there's a wee bit of resistance, but if you run your hand through water, there's much more resistance. So with a current flowing in the water, there's a lot more energy in there. And so it really is just the equivalent of wind energy, and you can see that with a lot of the turbine designs that people are looking at. They really look like big windmills. But of course, because there's so much energy there, because of the density of the water, you don't need the same speeds. And just as the wind flow over hills and things is quite turbulent and people are used to that, so the actual flow of tidal energy is very turbulent as well. And so when people think it's very smooth, that isn't the case. So things have to be designed to take that turbulence into account.
Tidal and wave power are the least common forms of renewable energy. To date, only 3 tidal and no wave power plants are in commercial operation. Costs for these sources are not yet competitive with others because of the expensive equipment that works reliably under constant buffering of the sea and that withstands saltwater corrosion.